The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Alrighty, before we go on and look at section 9.2 and 9.3 today, are there any questions from section 9.1 from yesterday? If so, speak now.
Yes, can we work on, or can you work on the last question for part one?
Okay, give me just a second here. And okay. All right. So you want the last question of 9.1 part 1?
Yes.
All right, it's coming up here. And let's see here. Okay. This is 9.1 part 1, and this is problem number 21. It says find the domain of the function, and the function is h of x equals the square root of 63 minus 9x. Okay, so we are to find the domain of this function. Now, we're taking a square root, which is in general an even root. You can't take an even root of a negative number. So that means that this quantity inside, that is to say 63 minus 9x, must be non-negative. It either has to be greater than or equal to 0, positive or 0. Okay? So solving that inequality, we'll subtract 63 from both sides. We'll divide both sides by negative 9. But when we divide both sides by negative 9, we change the direction of the inequality symbol. So we get x is less than or equal to 7. Writing that in interval notation, that would go from negative infinity up to and including 7. We'd have parentheses on negative infinity and a bracket on 7. Any questions on that? Sarah?
No, I think I'm good.
Good to go. Okay, any other questions, anybody?
Could you do the one with the graphing?
The one with the graphing.
Yeah, it was number, I believe, 22. Oh, I was looking for my paper. The one where it says graph, let's see where it is. I graph the function, 19.
Okay, Yesenia?
Yes.
Okay, let me find, let's see here. So is this 9.1 part 1 or part 2?
Part 1.
Okay. And it's problem 19, is that what you said?
Yes.
Okay, all right. Okay, so let's take a look at WebAssign. Okay, so we've got these 4 graphs, right?
Mm-hmm.
Now, the graph of the square root of x, what does that look like? Just the graph of the square root of x. From the other day, let's see here. Hang on a second. 2. I'm going to switch back to my whiteboard screen. This was the graph of f of x equals the square root of x, okay? When x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. When x is 4, the square root of 4 is 2, etc. Okay? You all right with that?
Yes.
Now, let's go back to our other screen. So the square root of x would have this kind of shape, like that, or like that, or like this. But this says -3. So what is -3 going to do? It's going to take that graph and move it down 3 units. So here it is, right there. Now, if that, it's like, no, I want to find it just using ordered pairs. We can do that. Okay, so let's go back here. And let's take a look at, let's see here. So we've got f of x equals the square root of x minus 3. Okay, now we are putting x into a square root, taking the square root of it, and then afterwards subtracting 3. So I'm going to use perfect squares for my x values, okay? Because the -3 is not inside the radical, it's after we take the square root. So if x is 0, f of 0 is the square root of 0 minus 3, which is 0 minus 3, which is -3. Okay, so I'm right there. So far, so good?
Yes.
Okay, how about 1? F of 1 is the square root of 1 minus 3, which is 1 minus 3, which is -2. So when x is 1, y is -2. Okay. 4. F of 4 is the square root of 4 minus 3, which is 2 minus 3, or -1. So we've got 4, -1. So we're getting this picture right here. Okay, now from that, I can see that it's either got to be this. Well, I got to go back to the other page here. Okay, sorry. It's either got to be this thing here or this thing here, right?
Yes.
Well, it couldn't be this, because what's the domain of this thing? Well, x has to be greater than or equal to 0, because otherwise you're taking the square root of a negative number. So you couldn't have any of these negative x values as inputs. You see what I'm saying?
Mm-hmm.
So it has to be this one down here.
So another question, when you're graphing in, you say use the has to be perfect numbers. How you end up knowing what are perfect numbers?
Well, perfect squares. Perfect squares.
Yeah. Those.
Okay. Okay, let's take a look at that idea. All right.
Like, do you use the odd numbers, even numbers?
No. Here. Okay. 0 times 0 is 0, right?
Yes.
So we could say 0 squared is 0. 1 times 1 is 1. So 1 squared is 1. 2 times 2 is 4. So 2 squared is 4. 3 times 3 is 9. So 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, etc. Okay, these numbers right here are called perfect squares. A perfect square has 2 identical factors. So like these situations, where you could write it as the base squared. If you unsquare, that is, take the square root of a square, you get back to a nice number. For instance, 3 squared is 9. The square root of 9 is 3. In fact, what about this? What's the square root of 3 squared? Well, the square root and the square will undo each other. What's the square root of 5 squared? It's 5. What's the square root of 17 squared? It's 17. So if the number inside is a perfect square, meaning it has 2 identical factors, and I take its square root, then that number comes outside. Okay, as long as
Okay, now I got it.
positive. Okay, all right. What else? Anything else before we go on? All righty. Then let's go on to section 9.
I had a question.
Yeah,
Sorry.
it's okay. What?
The very last one on the second part.
Okay, so hang on. Let's find yours. Let's see. So give me a second here. Got to figure out which class. Okay, I think it's the other one. And okay. So the very last one on the first part you said?
On the second part, number
Second part.
16.
So on 9.1 part 2. Number 16. Aha, I see that. Okay, hang on. All right. Okay, so can everybody see the picture?
Yes.
Okay, use a calculator to solve the problem, it says. The graphs of two radical functions shown in the illustration can be used to estimate the speed in miles per hour of a car involved in an accident. Suppose a police accident report listed skid marks to be 230 feet long, but failed to give the road conditions. Estimate the possible speeds the car was traveling prior to the brakes being applied. Round your answer to the nearest whole number. Okay, so what we've got to do is down here at the bottom, we've got the scale that's the length of skid marks, okay? And it said that our skid mark was 230 feet long. So looking at this scale, let's see, if this is 200 and there's 1, 2, 3, 4, 5. So each one of these hash marks would be 20, okay? Because you'd have 200, 220, 240, 260, 280, 300. All right. You seeing that, Jamie?
Yeah.
Okay. So 230 would be right there, halfway between those two. So if we come up here, right there on wet pavement. Oh, you know what you did? You've got.
I know. I put them backwards.
You got them backwards. Right.
Yeah.
Right. Yeah. Yeah. Okay. Now, and even so, let's take a look. So let's look at your answers. You said 50 and 75. So 75 is for the wet pavement, 50 for the dry. And again, this is where it's a good thing you can put in more than one answer, okay, for your homework, because if you're trying to get the 230 right there for dry pavement.
Well, it looks like I got the dry pavement.
Yeah, the dry pavement one's right. Okay, yeah. So the wet pavement, it's right there.
So they wanted 48, huh?
Yeah, and again, it's 50 looks like it's right over there, so it's a little bit less than that. So you're gonna have to kind of guesstimate, 46
Gotcha.
48. Okay with that?
Yeah.
Yeah. So you just had them backwards. All right. Anything else? Anybody? Okay, we're going to go on into section 9.2. And we're actually not only going to be in 9.2, but we're going to be going back to chapter 5.2 because 9.2 talks about exponential rules that were introduced in section 5.2. But now we're going to expand what we can use as exponents. Before we had positive and negative exponents and 0 as an exponent. Now we're going to have fractions as exponents. So for instance, let's say I've got the square root of 9. Okay. What is the implied index? It's a 2. Recall that when we're taking a square root, we don't bother to put a 2 in there for the index. If there's nothing for the index, it's an implied 2. All right, that is radical notation. If I want to write the square root of 9 using exponents, it becomes 9 to the 1/2 power. The index of the radical becomes the denominator of the exponent. So the square root of 9 is equal to 9 to the 1/2 power. Now this is not 9 times a half, because 9 times a half would be 4.5. and the square root of 9 is 3, okay? So don't treat it like it's a multiplier, it's an exponent. So in general, the nth root of a is equal to a to the 1 over n power. The index is the denominator of the exponent, okay? So if I had the cube root of 8, that would be 8 to the 1/3 power. If I had the 5th root of 73, that would be 73 to the 1/5 power. Are you getting the idea? Hopefully. All right. Let's say I have the cube root of 4 squared. This would be 4 to the 2/3 power. The index is the denominator of the exponent, but the power is the numerator of the exponent. Okay. So the cube root of 4 squared would be 4 to the 2/3 power. Any questions so far? All right. Let's see here. What would 125 to the 1/3 power be? So that would be equivalent to the cube root of 125, okay? Now, what we're going to do, we're going to put both of these into our calculator to see that we're going to get the same answer in both cases, which should be a 5. To put 125 to the 1/3 power into the calculator, I need to do this, okay? Calculator's on and it's cleared. I type in 125. Now I'm going to use the little caret key that's over on the left column, and it looks like that, okay? But I want 125 to the 1/3 power. Now, if I do this, it's going to give me the wrong answer. I have to tell the calculator that the exponent is 1/3. If I don't put the parentheses in there, it thinks I'm taking 125 to the 1 power divided by 3, okay? So you've got to group or parenthesize that 1/3 exponent. So 125 raised to the parentheses 1 divided by 3 power comes out as 5. Now let's go back and let's use the X root button. Recall that in that case, you have to put in the root first. So you go 3 and then second X root, 125, and I also get 5, okay? But the cube root is the 1/3 power. And using this button and then putting parentheses around your exponent is how you can enter this type of problem into your calculator. Okay, let's do this. Let's do 125 to the 2/3 power. Okay, so again on my calculator, 125, little caret key, 2 divided by 3, and let's see what we get. So 125 caret key 2 divided by 3, and I come up with 25. Any questions about that? Let's take a look at this problem again. This says I'm taking 125 and I'm going to square it as well as take the cube root of it. All right. Well, I can do it this way. I can square it and then take the cube root. Let's see, 125 squared is 15,625. Then I'm going to take the cube root of that. So I'm going to raise that to the 1/3 power, and I come up with 25. Okay, so I did the power and then the root. Since both the power and the root are real, neither one of them is taking an even root of a negative number, I could also do it this way. I could take the root and then the power. What would be the advantage of that? Well, for one thing, I wouldn't need a calculator because I wouldn't have to take 125 times 125. The cube root of 125, or 125 to the 1/3 power, is 5. And 5 squared is 25. So if both the root and the power are real, you can do either one first. Generally, it's going to be easier to do the root first. So you're taking a number, making it smaller, and then raising it to a power, as opposed to taking a number, making it larger, and then taking a root. They both work, but if you're doing it by hand, it's going to be easier in general to do the root first. Any questions about that scenario? Okay. How about this? Negative 216 to the 1/3 power. If I'm taking the 1/3 power, that's the cube root. Can I take the cube root of a negative number? Absolutely. Okay, let's see. What times itself would be negative 216. Oh, let's see here. 5 times 5 times 5 is 125. What's 6 times 6? That's 36 times 6. 36. 216. So it would be 6, but it would be negative, right? Because negative 6 times negative 6 times negative 6 is negative 216. So the cube root of negative 216 is negative 6. So negative 216 to the 1/3 power, because that's the same as the cube root. Okay, so you've just got to get used to this idea of radical form, exponential form. Okay, how about this? 1/16 to the 1/2 power. If you have a quotient raised to a power, you attach that power to both the numerator and the denominator of the quotient. Well, what's the square root of 1? That's 1. What's the square root of 16? That's 4. So 1 to the 1/2 power is 1. 16 to the 1/2 power is 4. Any questions on that example? Okay. Recall that a product raised to a power, you attach the power to each factor inside. Okay. So if I had AB to the 1/n power, that would be A to the 1/n times B to the 1/n power. Again, the outside exponent gets attached to each factor inside. So now let's say we've got this 4x to the 4th all to the 1/2 power. It says simplify each expression. Assume that the variables can be any real number and use absolute value symbols when necessary. Now, earlier in this chapter, they used a different description. They said, assume the variables are unrestricted. Okay. Now they're saying can be any real number. Basically the same thing. They're saying the variable could be positive or negative. Don't assume it's positive. You just have to, assume it could be anything and deal with it if you need to with absolute value bars. All right. So we have a product raised to a power. So this is going to be 4 to the 1/2 power, x to the 4th to the 1/2 power. Okay, so we're attaching the outside power to each of the factors inside. All right, now 4 to the 1/2 power. What is the square root of 4? That's 2. Here we have a power raised to a power. So if we've got a to the m to the n, a power raised to a power, you multiply the exponents. What you might want to do, and I know that in this course, we didn't cover section 5.2. We started with 5.4, but if you took Math 84, Math 85, or a beginning algebra course, you would have covered this. But if you need an extensive review, go back and take a look at section 5.2, like in your online textbook or your regular textbook, and you'll see all these rules again, but you might want to review that. Anyway, okay, so a power raised to a power, we're going to multiply the exponents. So this, x to the 4th to the 1/2, what is 4 times 1/2? It's 2. So this would be x squared. X to the 4th to the 1/2 power is x to the 4 times 1/2, or 2. Now, do I need absolute value bars here? No, I don't. Since the variable is being squared, even if it's negative, when you square it, that would make it positive. So this would be the answer. All right. Let's see here. Let's take a look at this example. X cubed to the 1/3 power. Again, a power raised to a power. You'd multiply the exponents. What's 3 times 1/3? That would be what? 3/3 or 1. So basically, it's just x. Now, I'm taking a cube root, so x could be positive or negative. So again, I don't need absolute value bars there, do I? Okay. How about this one? -16 q to the 4th, all to the 1/2 power. So this would be -16 to the 1/2 power, q to the 4th to the 1/2 power. Well, we've got a problem right there. We can't take an even root of a negative number. So raising it to an even denominator, I guess, okay, the exponent, because that's saying take the square root of it. So this is not real. It doesn't matter what this is. If any part of it's not real, the whole thing is not real. Okay. Okay. Let's see here. How about this one? -64 t to the 9th, all to the 1/3 power. So this would be -64 to the 1/3 power, t to the 9th to the 1/3 power. Well, now we're taking an odd root, because the 1/3 power is like the cube root. You can take an odd root of a negative number, and the cube root of -64 is -4, because -4 times -4, oops, times -4 is what? 16 times -4, -64. So this is -4, and this would be what? T cubed. Because a power raised to a power, you'd multiply the exponents. 9 times 1/3 reduces down to 3. Okay. Let's see. All right. It says evaluate each expression. 27 to the 2/3 power. All right. So this would be, I'm going to do the root first. What's the cube root of 27? That's 3. And then the power, so I get 9. If I did the power first, I'd have to take 27 squared, and that's huge. I don't want to mess with that if I don't have to. Okay, how about this one? This is kind of tricky, because what we have to remember is that if the base is going to be negative, we would have to have parentheses around it. And since there aren't parentheses around it, the base is actually just that, and that negative sign is outside of the base. So what we're going to do is we're going to have -100, take the square root of that, and then cube it. So I'm going to do the root and then the power. Okay. Now, what is the square root of 100? That's 10. And 10 cubed is what? 1,000. So my final answer is -1,000. Okay. Now, if you were going to put this into your calculator, you would not put parentheses around the negative 100. You'd just write negative 100 caret 3 divided by 2, close it up, equals, and that should give you negative 1,000. In fact, I'm going to do that right now. Let's see. Negative 100 raised to the 3 divided by 2 power, and I get negative 1,000. I don't know if you can see it, but there it is. Okay. If you need me to do any of these, like you want to see what's going on in the calculator, I could bring up a calculator online and punch numbers in there. So let me know if you need that. Okay.
Yeah, could you do that?
Sure. Okay. So let me see here. Of course, now having said that, hopefully I can get one to come up. Let's see here. Later. Okay. All right. So the one we just did was interesting. This one has a minus sign, but I don't see a different negative sign. Well, let's see what happens. If I put in negative 100, and then now here, this particular calculator I've got doesn't have a caret key. It has a x to the y power key, and it's the same thing. By pushing that, see how it opens up a little box here? So that little box is going to be my exponent. And again, some of you may actually have this. So on this online calculator, you use x to the y. On the calculator that I have, which is the TI-30XS, it has a little caret. Okay. And there you go. All right. Also this.
So you pushed.
Sorry?
So you pushed the X to the Y button and then you pushed 3 minus 2?
Okay, let's go back and do this again. So I had negative 100. I pushed the X to the Y button. Now, and again, I know this is going to be confusing because notice online, this little calculator has a box. Okay.
Yeah. Mine isn't like this at all.
What calculator do you have?
I have a Texas Instrument TI-30XA.
30XA.
And it's got all kinds of buttons.
Yeah, it's for an accounting class. Okay. But does it have the little caret key?
No, I don't know what that is.
Okay. Hang on. Let me just
It has a Y to the X button.
Okay. Yeah. So you're going to push the Y to the, so basically you put in the base, then you click the Y to the X button or X to the Y button, whichever one yours has. That's the same thing as what I'm calling the little caret key.
Okay.
Then you put in the exponent. And since the exponent is a fraction, I'm going to go 3 divided by 2 and close it up. Okay. So now I've got negative 100. Okay. Raised to the 3 divided by 2 power.
So then 1.5 popped up on my calculator.
Which is the same thing as 3 divided by 2.
Okay. So then I just put equals.
Right. So let's go back. So you could do this. You could go negative 100 y to the x, and then you could put in 1.5. Okay.
It just says error.
When you put in 1.5 or what?
Yeah. Well, I put in negative 100 y to the x power, and then I put in the parentheses, right?
Okay.
And you want me to put in 1.5?
Sure.
And then I put equals, and
No,
it says error.
you have to close the parentheses.
I did.
Let's do this, okay? Can you stick around at the end of class for a little
Sure.
while and we'll look at
Yeah.
yours and see if we can figure out what's going on there, Jamie? Okay.
Sure.
And you remind me if I forget. We'll come back to you
Okay.
on that. Okay. All right.
Okay.
So back to my whiteboard screen. So on my calculator, I would do this. On the online calculator, you would do that. So this and this are the same. I call them the power key, because when you push that, it's like saying -100 to what power? And then you put in the power. Okay. Yeah. All right. So let's continue on here. Where am I? Here. Okay. Let's say we've got 4/9 to the 3/2 power. Okay. We've got a quotient raised to a power. You attach the power to both the numerator and the denominator of the quotient. So this is going to be 4 to the 3/2 power over 9 to the 3/2 power. Okay. Now I can take 4 and cube it and get 64, and take the square root and get 8. Or I can take the square root, which is 2, and cube it and get 8. So again, I can do the exponent or the index, the exponent or the radical first, the exponent or the root, I guess I should say. Then 9 to the 1/2 power cubed. 9 to the 1/2 power is the square root of 9, which is 3, and 3 cubed is 27. Okay. So 4/9 to the 3/2 power equals 8 over 27. Any questions on that example? All right. Let's take this example. I've got 27 a cubed b cubed all to the 2/3 power. So I have a product raised to a power. So that's going to be 27 to the 2/3 power times a cubed to the 2/3 power times b cubed to the 2/3 power. Okay. 27 to the 2/3 power, I'm going to take the cube root and then square it. Okay. Which is going to be, what's the cube root of 27 is 3, and 3 squared is 9. So this is 9. But I have a power raised to a power, so I'm going to multiply the exponents. What's 3 times 2/3? That would be 2, because it'd be 6/3 or 2. Okay. And then b to the 3 times 2/3 power is also going to be 2, because 3 times 2/3, 3 times 2/3, the 3's reduced down and you're left with just a 2. So there's my final answer, 9a squared b squared. Okay, based on if you have a product raised to a power, you attach the power to each factor, and you can do the exponent first or the root first, as long as they're both real. And I recommend doing the root first. Okay, let's see here. How about this one? It says change each radical to an exponential expression. So this would be 7p squared q all to the 1/7 power. Okay, index becomes the denominator of the exponent, and I need parentheses because the whole thing is raised to the 1/7 power. How about this one? The square root of x squared plus y squared would be the quantity x squared plus y squared to the 1/2 power. It says change each exponential expression to a radical. So I've got 6x cubed y to the 1/4 power would be the 4th root of 6x cubed y. Another example, x cubed, oops, plus x cubed plus y cubed to the 1/3 power would be the cube root of x cubed plus y cubed. So again, changing back and forth between the two forms. Okay, now recall that something raised to a negative exponent is like 1 over that same base raised to a positive exponent. So 49 to the negative 1/2 power is 1 over 49 to the positive 1/2 power, which is 1 over, what's 49 to the 1/2 power? What's the square root of 49? 7. Eight to the negative 1/3 power is 1 over 8 to the 1/3 power, which is 1 over the cube root of 8, which is 2. 25 over 49, all raised to the negative 3/2 power. Recall, if you have, let's say, a over b to the negative n, that's the same thing as b over a to the positive n, because if you take the reciprocal of the base, it changes the sign of the exponent. So this becomes 49 over 25, all to the positive 3/2 power, which is the same thing as 49 to the 3/2 power over 25 to the 3/2 power. I'm going to do the root first and then the power, the root first and then the power. So I'm going to do the square root of 49 is 7. So I've got 7 cubed. The square root of 25 is 5 over 5 cubed. Let's see, 5 cubed is 125 and 7 cubed, I don't remember. Let's see here, 7 cubed, helps if you turn the calculator on first. So I think it's like 343. And my guess is if you're struggling right now with what I'm doing, it's because of the need to review those rules. This whole idea. Again, I think it's like at the very end of section 5.2, it has all the powers of the properties and everything listed. Okay, how about this? 4 to the 2/5 power times 4 to the 2/5 power. Well, again, the rule is if you're multiplying two powers with the same base, you add the exponent. So if I had x cubed times x to the 4th, that would be x to the 7th. Well, here I'm multiplying two powers with the same base, so this is going to be 4 to the 2/5 plus 2/5, which is 4 to the 4/5 power. So I'm adding the exponents. Any questions on that? Okay, how about this one? 5 to the 1/3 power times 5 to the negative 5/3 power. That's going to be 5 to the 1/3 plus negative 5/3, which would be 5 to the negative 4/3 power, which would be 1 over 5 to the positive 4/3 power. So what did we do? We're multiplying two powers with the same base. So we added the exponents to get that. But then we rewrote this by taking the reciprocal of the base and changing the sign of the exponent. So a couple of different rules there. Okay, what about this one? 2 to the 5/6 power times 2 to the 1/3 power over 2 to the 1/2 power. Okay, so on top I've got 2 to the 5/6 plus 1/3 power. But I need to add 5/6 plus 1/3 because I'm adding the exponents. How do you do that? Well, you need a common denominator, which in this case is a 6. So I'm going to multiply 1/3 by 2 over 2. So 1/3 becomes 2/6. 5/6 plus 2/6 becomes 7/6. So this is 2 to the 7/6 power over 2 to the 1/2 power, and we're not done yet. Take a look at that, see if you got any questions. All right, so if let's see here, let's go back here. Multiplying 2 powers with the same base, you add the exponents. Dividing 2 powers with the same base, you subtract the exponents. You subtract the bottom one from the top. So like x to the 7th over x to the 3rd would be x to the 7 minus 3 or x to the 4th power. You subtract. So here, dealing with that, this is going to be 2 to the 7/6 minus 1/2 power. Top exponent minus bottom exponent. Well, let's see. 7/6 minus 1/2 is going to be 7/6 minus, I'm going to have to multiply by 3/3. So 1/2 becomes 3/6. And now we've got 7/6 minus 3/6, which is 4/6. But that reduces down to 2/3. So we've got 2 to the 2/3 power. I know you're thinking, man, I should have stayed in bed today. Should have skipped this meeting. I know. Again, go back and review those rules. It'll help a lot. Okay, let's see here. Let's take a look at this one. Y to the 2/5 power times y to the negative 2/5 plus y to the 3/5. So we're going to distribute. Okay. So I'm going to take y to the 2/5 times y to the negative 2/5 plus y to the 2/5 times y to the 3/5. Okay, so I'm distributing the y to the 2/5, multiplying it by each term in the parentheses. Now let's take a look at this. What am I doing? I'm multiplying 2 powers with the same base, so I'm going to add the exponents. So 2/5 plus negative 2/5 would be y to the 0 power. Recall, anything to the 0 power other than 0 to the 0 power is 1. And then plus. So here, multiplying 2 powers with the same base, add the exponents. Y to the 2/5 plus 3/5, which is y to the 5/5, which is y to the 1, or just y. So I've got 1 plus y as my final answer. All those fun rules. Okay. This says use radical exponents to use rational exponents to simplify each radical. So what we're going to do, it may seem kind of crazy, but I'm sure you're convinced that I'm crazy by now anyway. We're going to take this radical expression, we're going to write it as an exponential expression, simplify it, and change it back to a radical expression. So the 4th root of 5 squared would be 5 to the 2/4 power. The power's on top, the index or the root's on the bottom. But this could be simplified down to 5 to the 1/2 power, because 2/4 reduces to 1/2. But that's just the square root of 5. So this becomes that. How about this one? The 12th root of 13 to the 4th power. That would be 13 to the 4/12 power, which is 13 to the 1/3 power, which is the cube root of 13. So again, once we turn it into exponential form, if we can reduce that fraction, that's how we can simplify. Okay. How about this one? The sixth root of x squared y squared. So that would be x squared y squared to the 1/6 power, which would be x squared to the 1/6 power times y squared to the 1/6 power, which would be x to the 2/6, y to the 2/6, or x to the 1/3, y to the 1/3, or the cube root of xy. All right, we're going to take a break. So I'm going to stop the recording. We'll come back here.